Hello to the Ina. My name is Ong Jing. We are from Group 20. Today, we are going to present a study on proposed industry information treatment system (ITS) and a wastewater treatment plant WWTP at Kilang Kokope and Nursery Sungai Marong Agrifen in Kutas Malahan. And next, you can see this our group member. Next, moving on introduction, ITS is a wastewater treatment used in industry. The purpose is to eliminate dangerous compounds to complete remediation. The wastewater must be treated according to Environmental Quality Act 1974, which is categorized to Standard A and Standard B before it discharged to the river. Next is our project breakout. The figure shows the location of Kilang Copper and Nursery Sungai Merah Aquifer, and the size area is about 11.38 hectares, and the area is measured by Google Maps. The purpose of this project is to manage and treat wastewater generated for the cocoa production process and to ensure the the wastewater compete with the OE standard A and B before discharge to the environment. Right now, the farm has no proper treatment system and simply store the wastewater in the pond. This is a major risk because the farm is expanding and sits right next to the Sungai Sabang. So our proposed treatment plan solve this based on three symphonies: environmental protection, operational sustainability, and legal compliance. Next, let's look at the water consumption and wastewater characteristics. The factory used about 8 cubic meter per day to soften the coconut shape. As you can see, the wastewater in the storage tanks is bright brown and filled with hydroorganic. If directly discharge this untreated wastewater in the environment would be direct reverse, which is we need this treatment system. And this is for me, so I will pass the presentation to the Joyce. Thank you.
Therefore, the industry effluent treatment system will be designed and proposed in this factory. We have proposed four segments of treatment for this IETS. The first one is the preliminary treatment, followed by primary treatment, secondary treatment, and the last one is tertiary treatment. Now, the first one is preliminary treatment. This treatment removes large solids and debris to avoid harming downstream pipeline and equipment. There are two parts in this treatment, which is the bar screen and the grid removal. For the bar screen, it captures large, coarse floating solids such as coconut fibers and debris to prevent clogging during the treatment. And for the grid removal, it captures smaller, heavy inorganic material like sand, gravel, and grit that manage to pass through the bar screen. It also uses gravity to let this heavy particle settle rapidly to the bottom of a specialized chamber. Now let us move to primary treatment. This treatment is to remove the suspended solid, oil, and protein debris from raw wastewater, reducing the number of suspended particle and organic debris. This treatment also contains two sections. The first section is the balancing tank, which can also call the equalization tank. The function of this tank is the early stage vessel designed to collect, mix, and homogenize the raw wastewater, balance flow rate and organic load before the downstream treatment. It also ensures steady and consistent flow of wastewater to improve the treatment of performance. And for essential for cockpit wastewater due to fluctuating solid and organic content. The primary clarifier acts as the second section of the primary treatment. The function of this primary clarifier is use the natural gravity settling to separate the heavy organic solid and floating debris from the wastewater before the biological treatment. It also protects the rest of the treatment plant from damage and ensure that everything runs smoothly. The proven efficiency of this primary clarifier as the suspended solid removal and the organic load reduction. And for the design parameter, we set to 20 meter cube per meter square per day for our surface overload rate. And for the tank geometry, we configure to a 6 to 1 lane to width ratio for optional horizontal flow settling. Now let us move on to secondary treatment. This treatment is biologically remove the contaminants from water using the aerobic microorganism. The first section of this treatment is aeration tank, also known as the activated slug process. It designed it is designed to eliminate dissolved organic matter remaining after the primary clarification. It uses the aeration blowers to continuously introduce low pressure air through a submerged grid of diffuser. The second section of the treatment is the secondary clarifier. It adds settling stage that come after the biological treatment and separate the activate sludge from treated water. It keeps solid out of the final effluent while creating a stable sludge stream for return or further treatment. It also prevents the solid discharge into the receiving water and improve the final effluent quality.
Moving to tertiary treatment, the main purpose is to further polish the wastewater after primary and secondary treatment. The tertiary treatment consists of three main components, which are filter, disinfection, and TSE. Firstly, the filtration system is used to remove the remaining suspended solid, fine particles, and turbidity from the wastewater. For this project, a dual media filter is proposed using layers such as anthracite and sand. This type of filter is suitable because it improves water clarity, has better filtration efficiency, and can operate for a longer period before backwashing is required. Next, the disinfection tank is used as the final safety step to remove or inactivate harmful microorganisms before the treated water is discharged or reused. Chlorination is selected because it is simple, cost-effective, and suitable for the relative low wastewater volume from cocoa peat production. It also provides residue protection, meaning the water remains disinfected for a certain period after treatment. Lastly, the TSE tank, or also known as treated sewage effluent tank, is used to store the treated wastewater before discharge or reuse. It helps control the flow and allows any remaining particles to settle. The treated water can then be reused for non-potable purposes such as nursery irrigation or safely discharged if it meets the required standards emission and noise disturbance. Next is the existing environment of the proposed location. Firstly, in terms of physical site characteristic, the location is suitable because it is an existing usable patch of land. This helps reduce major site clearing and deforestation. It is also located at a lower ground compared to Kilang Cocoa Pit and Nursery Sungai Marong Agri Farm. Therefore, wastewater and surface runoff can just flow naturally by gravity to the treatment system without the need for pumping. The area is also relatively flat and near Sungai Marong, which reduces the need for heavy cutting and filling works during construction. Next, for land use, the surrounding area mainly consists of agricultural land, nursery beds, rural areas, and also natural vegetation. From the Google Earth view, there are no obvious commercial developments, religious center, or eating places nearby. This makes the site generally suitable according to the Malaysian Sewerage Industry Guidelines. From socio-economic aspect, the area is mainly supported by agricultural activities. The nearby workers include farm workers, nursery workers, tractor drivers, and administrative staff. Since Sungai Marong may also be used by the local community for small-scale activities, it is important to treat the wastewater properly before discharge. Next, I will talk about the Environment Impact Assessment EIA. It is important because the cocoa peat factory may produce wastewater and high organic content, suspended solid, and chemical residue. Therefore, EIA helps ensure that the treatment system complies with the Environmental Quality Act and reduce pollution risk. The impacts can be divided into three stages, which is pre-construction, during construction, and post-construction. During pre-construction, impacts may include minor vegetation clearing for site surveying and possible concern from nearby communities. This concern may be related to odor, noises, insects, or possible contamination. During construction, the main impacts include soil erosion, surface runoff, air pollution, noise, and vibration. Excavation and earthwork may expose loose soil, which can be washed into nearby water bodies during rainfall. Heavy machinery may also produce exhaust emission and noise disturbance. During post-construction, the impacts are mainly focused on the operation and maintenance. These include possible treatment plant failure, accidental effluent spill, sludge accumulation, bad odor, chemical leakage, and the need for regular maintenance. If these issues are not properly managed, they may pollute Sungai Marong, affect aquatic life, and cause discomfort to the surrounding communities.
To ensure sustainable industrialization, our project has been designed to align with the Sustainable Development Goals (SDG). Our project aligns with 3 different SDG, which are SDG 6, Clean Water and Sanitation, SDG 12, Responsible Consumption and Production, as well as SDG 14, Life Below Water. To mitigate the risk, we implement strict engineering measures. During pre-construction, geotextile silt fences and sediment traps are installed in case of rainy construction windows, whereas during the operational phase, carbon filters are installed to filter any hazardous gas before release, as well as for operational mitigations. We build the storage tanks using reinforced concrete walls, as well as ensure it has 110% safety capacity. The project is also designed to satisfy the occupational safety guidelines, which is why the HIRAP matrix is formed. So by identifying the risk, mitigation measures, and possible consequences, as well as knowing the risk score, we're able to provide engineering controls as well as PPE to ensure these risks are taken care of.
Based on our findings, we recommend implementing the proposed IETS to ensure compliance with environmental regulation and protect the nearby river ecosystem. Regular monitoring, staff training, and proper sludge management should be carried out to maintain efficient operation. Future expansion should also be coordinated with the Department of Environment to ensure continued compliance and sustainability. In conclusion, the proposed IETS will effectively treat wastewater generated from cocoa peat processing through preliminary, primary, secondary, and tertiary treatment stages. The system will help reduce pollution, comply with Malaysia's environmental regulations, and protect the surrounding river ecosystem while supporting sustainable operation of the factory. Let's conclude our presentation on the proposed industrial effluent treatment system for kilang cocoa peat and nursery Sungai Marong. Thank you.